Hello, today we did lesson 5, subtract fractions with unlike units using the strategy of creating equivalent fractions. Now remember, we've been creating equivalent fractions using the rectangular fraction model. That is a good model. We are going to keep using the rectangular fraction model to really help the kids understand the parts, the whole, where we're subtracting from, so they can visually see it before we go to that abstract thinking and just using the equation. So our first question in the homework states the picture below shows 3/4 of the rectangle shaded. Use the picture to show how to create an equivalent fraction for 3/4 and then subtract 1/3. So using the picture below, the easiest way to show an equivalent fraction of 3/4, since we're trying to make it into thirds, let's go ahead and, because we know that this is going to be 3/4 minus 1/3. So we're still going to use the rectangular fraction model to subtract. So here's my 1/3. Well, they started theirs horizontally, and typically I start mine vertically. So they started theirs horizontally. So I'm going to go back and recreate my 1/3 vertically. Now remember, it doesn't matter which way you start, as long as you do not do the second rectangular fraction model with the same kind of line. So if you start horizontally, make sure that it's only the first one horizontally and the second one vertically. I like to tell the kids, pick one and stick with it every single time you do it, trying to get them in a habit. So we're going to do 1/3. All right, and then shade that in. Well, it's an easy way to make 3/4 an equivalent fraction and be able to subtract 1/3 is to easily just make our rectangular fraction model over here equivalent to this one over here. So what we're going to do is we're just going to take our two vertical lines, so 1, 2, we're going to put them over here, 1, 2. And then to make 1/3 equivalent to our 3/4, we're going to take our 1, 2, 3 horizontal lines, 1, 2, 3 horizontal lines, and now we have the same models. They look exactly alike. They are equivalent rectangular fraction models. They are equal to each other. The only difference is how much is shaded. So now let's try to figure out how much we have shaded. Now I'm trying to teach the kids and help review the fact that we can solve what our whole is by using the formula for area. So length times width. So what is our length and what is our width? So we have 3 times 4. So we have a total parts of 12. And then over here we have let me erase these real quick. We have 3 by 4 again, which is 12. Again, I told the students, if these do not match, if these are not equal, then we need to go ahead and either recalculate and recount our boxes or go ahead and redraw everything, because we should have the same denominator by this point. So now we need to figure out how much we have shaded. So let's count the shaded part. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4. Now what we learned today is that all we're going to do is we're going to subtract our shaded boxes from our shaded boxes over here, and we're going to signify that by putting an X. So 1 shaded box, 1 shaded box, 2 shaded box, 2, 3, and 4. So now we have all of these taken out from our 3/4, or now 9/12, and we're going to get 5/12. So we have 1, 2, 3, 4, 5 shaded left of the 12. Now the students will love to just show it numerically, but we're still showing it pictorially, and I want the kids to keep showing it pictorially until we move on from this, because I want them to get in the habit of this is why this is happening. So let's look at the next one. So again, it says find the difference, use a rectangular fraction model, and common denominator. Simplify your answer if possible. Again, we're just going to keep drawing rectangular fraction models. I'm going to show it on A, B, the rectangular fraction models, and then I'm going to show it on E and F. I'm not going to do it on all of them, but I do believe, because it's the same process over and over again. So I am going to put the answers for C, D, but I am going to work out the word problem. So let's get to A. So A states 5, 6 minus 1/3. So we're going to draw our rectangles. I'm going to do mine nice and big. Again, they might use a separate piece of paper. It doesn't matter. Again, and like I said earlier, I like to start vertically. So 1, 2, 3, 4, 5. Make sure we partition this into 6. So 1, 2, 3, 4, 5, 6. And then we have 5 shaded. I'm going to change my color for the shading. 3, 4. Oh, probably shouldn't use gray. It's blending in with the paper there. Let me change it to red. I'm going to change to red. 1, 2, 3, 4, and 5. And then over here we have 1/3 horizontally. Again, changing that color to 1/3. And now what do we have to do? We have to take our vertical lines over here. So 1, 2, 3, 4, 5. Put them over here. 1, 2, 3, 4, 5. And then we have 1, 2 horizontal lines that we need to put over here. 1, 2. So now we need to state what is our new fraction. Well, our new fraction is a 1, 2, let's erase this. Remember, we're going to use the formula for area to solve. So 1, 2, 3, 4, 5, 6. We have a 6. Sorry about that. Let me erase that. We have a 6 by 3, so 18. 6 times 3 is 18. And over here we have a 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3. 6 times 3 is 18 again. Remember, area equals length times width, or A equals L times W. And this will pop up again. We are going back to area eventually. So I might as well review it as much as we can right now. All right. So now we need to figure out how much we have shaded. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15. And I have 1, 2, 3, 4, 5, 6. Now again, of course, they can find it numerically. Easy for them to find it numerically, but we're going to cross out. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what do we have now? So we can either count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 18ths. And then we can check that numerically. 15 minus 6 is 9 18ths. Or 1/2, because 9 is half of 18. We can rewrite this as 1/2. Let's go on to the next problem. And again, we're just going to keep doing this over and over again. The rectangular picture fraction model, I mean. So 2/3. I might draw this one a little smaller because I have 2/3 minus 1/2. I'm not going to have as big as a denominator. Sorry, let me rewrite this answer over here. So 2/3, 1, 2. We have 2 parts. Oh, let me color in. Let me shade these. I'm going to shade them with this. All right. And then we have 1/2. Shade with this. So 1/2. And then again, we're just going to take our one horizontal line and we're going to bring it over here. And we're going to take our 1, 2 vertical lines and bring them over here. And something I've noticed that the students are messing up on is like they'll draw a line like that and then they'll put a little one right there. And unlike how it's showing right here, what will happen is, let me fix this real quick and I'll show you. So they'll shade this in. They'll draw this line and then accidentally go like that. And they might, they're messing up on the drawing aspect of it. So they'll count this as 1, 2, 3, 4. So we need to help them with their drawing and make sure we're getting neat rectangular fraction models. Now they don't have to be perfect, but I do want them to be a little neater than what we've been getting. All right. So now let's find the area of our boxes. So I have a 3 by 2, which is 6, and I have a 3 by 2, so 3 times 2 is 6. What do I have shaded? 4. What do I have shaded? 3. Now let's go in and let's go ahead and mark out 1, 2, 3. 1, 2, 3. So pictorially, I ended up with 1/6, and 4 minus 3 is 1/6. Now let me give you the answers to C and D. So C is 7/12. D is 3/10. Go ahead and try to work those out. Let me flip to the next slide. Pause it if you need to. 2/3 minus 2/5. So as you notice, we have more parts to shade in this one. Our first two over here, you see that we only one of our fractions has a part, more than one unit of that part. So we're gonna have some in both. Oh, look at that! The book forgot to put our. Hopefully, students don't get distracted by that. I forgot to put in the lines for our fractions. All right, so 2/3 minus 2/5. 1, 2, 3, 4. Go ahead and shade them in. So I have 1, 2, and I have 1 and 2. Again, what do we have? We have 2 vertical lines over here. We need them over here. And we have 1, 2, 3, 4. I have 1, 2, 3, 4 horizontal. So we need 4 over here. We'll erase these right here. All right. So now we need to find what is our denominator. How many parts do we have total? So we have 3, 1, 2, 3, 4, 5. 3 times 5 is 15. And then over here we have 3, 1, 2, 3, 4, 5. 3 times 5 is 15. So we have 15 total parts. But how many do we have? How many can we shade? How many pizzas of pizza do we have? Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. And then right here is something I want you to notice as well. See how it barely goes across that line? Sometimes the students don't fully shade the whole box. So what will happen is they'll stop right here, say in this box, and they won't count this piece. But we need to make sure we're getting a full coverage. So this needs to be all the way down. All the way down. All right, let's count this. So let's go ahead and take away. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So we have 1, 2, 3, 4. Oh. And we still have 15ths as our denominator, and then 10 minus 6 is 4. So 4 15ths. All right. So let's erase all this. And then 5/7 minus 2/3, same thing. I'm going to let you do this one on your own. I get 1/20 first. Let's look at these word problems. Robin used 1/4 a pound of butter to make a cake. Before she started, she had 7/8 of a pound of butter. How much butter did Robin have when she was done baking? Give your answer as a fraction of a pound. So we're giving it as a fraction of a pound. So we need to figure out how much did she start with? How much did she use? And then finally, how much was she left with? All right, so those are the 3 questions, and then this is that final answer that we're looking for. So how much did she start with? Well, let's read the question. Robin used 1/4 of a pound of butter to make a cake. Before she started, she had 7/8 pound of a butter. She started with 7/8. How much did she use? Robin used 1/4. So how much was she left with? That is the question. So let's see. What do we know how to do to solve this problem? We know how to use a rectangular fraction model. So let's go ahead and I'm going to start it off. So we have 7/8 minus 1/4. So let's see what you get. I should see pictures. I should see a written response. And I'm going to give you what the answer is because I want you to get it correct. So we have 5/8. She was left with 5/8 pound. right, so she was left with 5/8 pound. See if you can use that rectangular fraction model. Remember, you're going to do it pictorially and numerically. So I need pictures, numbers, the subtraction sentence. And then the last question. Katrina needs 3/5 kilogram of flour for recipe. Her mother has 3/7 kilogram of flour in her pantry. Is this enough flour for the recipe? If not, how much more will she need? All right. So she needs, how much does she need? Does Katrina need? How much does she have? Oops. And then, does she have enough? If not, how much? How much more does she need? All right, so how much does Katrina need? Well, Katrina needs 3/5 kilogram. Her mother, so how much does she have? Her mother has 3/7. Is this enough flour for the recipe? Well, I know through the fact that depending on what our denominator is, tells us how many parts we have total. So the smaller the denominator, if the numerator is closer to the denominator, depending on its size, we can tell that 3/5 is bigger than 3/7 because there are 5 parts in 3/5 and 3/7 there are 7 parts. So that means that there are, if we had a whole pizza, and we had one box of 3/5 and one box of 5ths and one box of 7ths. So let's try to put this in the 5ths. This might not be perfect. So this is 4ths, and then 5ths was a little hard. Maybe we should have done squares, but this is all right. Yeah, let's do squares since we've been doing a big rectangular fraction model. So if we did squares, and I'm going to try to make them as even as possible. Let me see if I can just draw a square. Oh, there we go. We'll just draw a square. Let me erase this one. These squares are a lot nicer than mine. Can I move that one? I don't think I can move that one, so we're just going to have to hope that they're about the same size. So say these are identical, and we have 1 in 5ths, so 1, 2, 3, 4. And then we have 1 in 7, so 1, 2, 3, 4, 5, 6. Not perfect. I know, this one's a little spacey. But you can just tell already that even though this one's bigger, that it's still only the size of 1/5, but these are all smaller. So if we have 3/5, so 1, 2, 3, we still have more than 1, 2, 3 7ths because of the fact that we have to share more of the whole among 7 compared to among 5. All right, so that's like having to share one piece of pizza among 5 friends compared to 7 friends. You'll get more pizza if you're sharing with 5 friends than 7 friends. So we can also check because the fact that their numerators are the same, but this denominator is smaller, we can automatically tell that this is more than 3/7. So no, she does not have enough. If not, how much more does she need? Well, to figure out how much more she needs, it's a simple subtraction problem. We're just going to do 3/5 minus 3/7. Find out what that is using the rectangular fraction model. And then numerically, what is that going to be? So we should get numerically. What is that? What are my, I don't know why I'm drawing 2s. What is my fraction going to end up be? So again, numbers, pictures. Of course, I'm going to give you the answer because I want you to be able to find it. You'll end up with 6/35 kilogram. All right. Well, that's all. We had some birthdays today. Again, happy birthday to you too. I hope you have a good night. And even though it's your birthday, have fun doing homework. All right. See you guys tomorrow. Stay warm.